Hey functions class, we are going to multiply and divide rational expressions. So that is going to be the header of our next section. So now, to multiply and simplify a rational expression, the first thing you're going to do is factor. So make sure you factor what you see, and then you're going to look for those giant ones like we were with simplifying. Then you're going to multiply top times top equals top, and bottom times bottom equals bottom. And basically, that's going to be combining like terms if we need to, that kind of thing. And then we're going to simplify. So go ahead and get this down in your notes. Hit pause. All right, so here's your first example. Make sure you get this down in your notes. Go ahead and hit pause, and I will get ready. So the first thing I like to do when I am looking at a problem like this is, since this is multiplication, I can go ahead and just put parentheses around everything like this, and make this all one problem. So when we do that, we have it all one problem. Now I need to factor. So the reason why I want to factor is because I've got these pluses and the minuses right here, and I can't break them up, and I can't start finding my big ones. So the first one I want to do is I want you to hit pause, and I want you to factor through this whole thing. Okay, so I went ahead and factored. I went ahead and did it in two different colors so you could kind of see what I was doing. So I did a greatest common factor for the c squared plus 2c because I could see that they both had a c in them. When I did the GCF, I ended up with c times c plus 2. So this is the same as this. And then I did a box and diamond for my c squared minus 4c plus 4 because there was no greatest common factor, which I checked for, and then I did box and diamond. And then I did a denominator. So I did the denominator in blue so that you could see the work and follow along. So c squared minus 4 is a difference of squares. So I did a square root of each of those, and I put them in my pattern, which is c plus 2 and c minus 2. And then here, this is something that students typically miss. So I could see that this is the greatest common factor with the c squared minus c for the same reason as up here. They both have a c in common. So make sure when you do a greatest common factor, I have c squared minus c. I can see that I can pull out a c. So c times c equals c squared. C times negative 1 equals negative c. So we have to be careful with that negative 1. A lot of us miss that. So now when I'm multiplying and dividing, I'm going to find things that are exactly on the top that are on the bottom. So things that are identical. And I usually just go through it, and I start at the beginning and I work my way to the right. So C, are there any lone C's? Well, there is. I have a 1, there's a 1 right there, and that makes it C over C, which is 1. And then I have a C plus 2 and a C plus 2 right underneath it. So this is 1. So that we call these our big ones. So I guess this could be a 1, 2. It's just kind of separated because of how I factored. And then C minus 2. So there's 1 right here. And they have to be on top and bottom. They can't be next to each other like those ones. And then is there another C minus 2? There is not. So now this says that 1 times 1 times 1 times 1. So 1 times 1 times 1 is times c minus 2 over all of that. So we are just going to write c minus 2 over c minus 1. And then that is it. So that is fully simplified. And when we multiply and divide, we're not going to find the domain because there's usually too many. There's too many. So we're not going to ask you to do that for these. Okay, here's another example. I would like you to get it in your notes and go ahead and try this on your own. Okay, so I went ahead and factored this. The only thing I really needed to factor was the m squared minus 16, which is a difference of perfect squares. So I've got m plus 4 and m minus 4. This is a multiplication times 1, because that's this right here. And I went ahead and left it there just so you could see where I was going. And then I took the m plus 2, put parentheses around it, m plus 4, put parentheses around it, and put it on my denominator. So now I just have to find the things that are exactly the same on the top and the bottom, and I just start from left to right. So m plus 4, nope, that's not it, that is it. This is a big 1. And m minus 4, nope, that's it. So then fully simplify, we have m minus 4 over m plus 2. So that is it. So make sure first you factor and then you go on. All right, now we're going to divide rational expressions. So if you want to put another header in, again, to divide a rational expression, we are going to multiply by the reciprocal. And multiply by the reciprocal, that is, so if we had fraction a over b divided by c over d, we would rewrite that as a, keep this one the same. We're going to change that to multiplication. And we're going to multiply by the flipped fraction. So multiplying by the reciprocal is keep, oops, I wrote that in the wrong spot. Sorry. Keep the first fraction the same, change the sign, and flip the second fraction. So keep, change, flip, keep, change, flip. Then we are going to factor, and then we just basically multiply. Now it's a multiplication problem, and we know how to deal with that. So go ahead and get this example in your notes, and we will do that. Get this example in your notes, and let's set this up. So we need to keep the first fraction the same. So I'm just going to put it in parentheses. We're going to change it to multiplication, and we're going to flip the next fraction. 15p plus 6. Okay, so now we have a multiplication problem. With all those parentheses, we can just make it all 1. And we need to factor. Does 5p plus 2 factor? No, it does not. And does 5 factor? Nope. So I'm going to rewrite it as 5 times 5p plus 2, because that says the same thing with less writing. And then we have the 6 here, and then we are going to do a greatest common factor. So 15p plus 6 as a GCF. I can factor out a 3. So I would multiply by 5p. 3 times positive 2 will get me 6. So then I have 6. I'm going to put the 3 out front. 3 times 5p plus 2. Okay, so then we can start looking for our big ones. There's no other 5 but a 5p plus 2, so this is a big one. So then we end up with, so this is where we would multiply and divide multiply left to right. So then we have 5 over 6 times 3, which is 18. And that is our final answer. So go ahead and put this one in your notes. This one is a little bit different. You will see this in your homework. So what we're going to want to do is we're going to want to put the keep, change, flip. So we want to multiply by the reciprocal. So we're going to have q squared plus 2q. But then the second part, this right here, so then we're going to have 3q minus 6. And then 5, so this says 5 plus q. I'm going to rewrite that in standard form, and I'm going to write q plus 5. And then this one right here is 4 minus q squared. This is a special case. When we have a perfect square here and a minus sign and a perfect square here, but this is the variable and this is the constant, we want to be careful, and we're going to actually want to factor a -1 out so that the q squared is positive when we write it. It's just something mathematicians do, and it'll help us in the long run. So the first thing we're going to do is we're going to factor out a -1. So -1 times a -4 and a -1 times a positive q squared will get us the answer, will get us the positive q squared. So we are going to put the -1 right here. And then we're going to write this in standard form. So the q squared minus 4. This is something that we don't typically do, but it will come up. So when this number, when the variable is negative like this, we're going to want to rewrite it as a positive. And the way that we rewrite it as a positive is we factor out a -1. It's still a difference of squares. We're still going to get that, and we'll still get the same factors. This just looks a little more comfortable, a little bit more what we're used to. So now that we have this set up as a multiplication, because I kept this one the same, that's right here, and then I flipped this one, and I did some extra work. I rewrote it in standard form, the denominator. Go ahead and factor that. Okay, so I went ahead and factored it. I have got the q. I did a greatest common factor, so I ended up with q plus 2. And then I factored out a 3. I did another greatest common factor, 3 times q minus 2. And then q plus 5 doesn't factor any further. Negative 1 doesn't factor any further. And q squared minus 4 was a difference of perfect squares. So now I can start looking for my big one. So I have a q. Well, there aren't any q's by themselves. And then I have a q plus 2 and a q plus 2. So right here is a big one. 3, I don't have any 3's. A q minus 2, here's another big one. And so then I end up with, I want to put my numbers up front just in case. So 3 times q, so that's written right. And then I have negative 1 times q minus 5. I'm sorry, q plus 5. Which 3 divided by negative 1, we need to simplify that further, would be negative 3q over q plus 5. So that negative would go up front. We usually don't want a negative in the denominator. All right, so those were my last couple of examples. If you have any questions, please let me know, or please let Ms. Wadley know. Thank you so much, and have a great day.